Hey guys, it's Mrs. Wallace. This is the question about the contraltos and the sopranos. So I figured I would just take a couple minutes to give you a sense of this question, and if you have not yet tried to do this one on your own, there's a couple of things about this question that you might be interested in. First off, this question is set up a little bit differently than the one before. The one before, the data set that you're given is representative of one firm in a 3-firm oligopoly, right? In this case, you're actually looking at industry data, okay? So it's almost as if, like before, you had 3 firms that you had to, kind of figure out the data for one firm. If one firm was producing 5, then you had to multiply it times 3 in order to know that the industry was producing 15 units. In this case, it's going to be the opposite. This is now the industry, so we kind of have, one firm, right? This is the one firm. If we know this one, this is a 2-firm oligopoly. Our data is representing just kind of one monopoly graph with both firms' revenues and costs combined, okay? So if we want to know what's happening to each firm, we have to kind of either divide by 2 or consider what the distribution is based on a cartel contract. And because this is a cartel, we know that this is a colluding oligopoly. A cartel is really a word that describes the written contract that 2 oligopolists might produce, in order to ensure that neither one of them would cheat on this agreement. Of course, it happens anyway, but cartels have the added advantage of adding some teeth, and we would see a lot of informal types of tacit collusion maybe done without a actual cartel, but essentially with teeth, based on some other means of making sure that people follow the agreement. In any case, we are given 2 pieces of information when this problem is given to us. We're given the price of olive oil and we're given the quantity of olive oil. Okay, so note that basically we're looking at the information that's on the demand curve, right? So, basically you're given the price, you're given the quantity at a higher price, right? What is happening? The quantity is lower. At the lower price, we have a much higher quantity. So this is just kind of points on the demand curve. So always think of price and quantity as essentially your demand curve. What we don't have in our data is marginal revenue. And that means we don't have, this piece right here, our marginal revenue, and we need marginal revenue in order to figure out what the profit maximizing quantity is so we can figure out our price. So with this, there were a couple of things you had to figure out. You really have to figure out marginal revenue, and you have to figure out also marginal cost. It's not here. Marginal cost is relatively easy because it is going to be constant and it is $40. They tell us that in the problem. Okay, so the marginal cost, I should have typed that, sorry, but you guys get the idea. The marginal cost is 40, and it doesn't matter what the quantity is, it's always going to be a marginal cost of 40, and because there's no fixed cost, we're just using marginal cost to kind of figure out what our total cost will be. In terms of marginal revenue, remember, and this is a little bit weird, marginal revenue is the change in total revenue over the change in quantity. So in this case, it's easy to kind of see the change in total revenue. So if we kind of increase our production from 1,000 to 1,500, we're increasing our revenue, but we're also increasing our quantity. So change in total revenue is $35,000, but the change in quantity is 500, right? We're not in intervals of 1 here, so you have to make sure that you do that when you put together your marginal revenue. So make sure that this right here is looking kind of similar to the way it does here. Some of you might have bigger numbers here. That's been like kind of a common student mistake. So just make sure that you've got, your first increase in 500 units leads you to a marginal revenue of 70. The next increase in 500 units leads you to a marginal revenue of 50. Okay, and you would essentially continue to produce until you get here. When you start to produce 2,500, your marginal revenue would be 30, okay? So you wouldn't produce that because 30 is less than 40, okay? So we can suggest marginal revenue is not equal to marginal costs when the firm is when this oligopoly is producing 2,000, but it is as close as possible, right? Marginal revenue is 50, marginal cost is 40. At least our marginal cost is not greater than our marginal revenue. And here we can start to do a little bit of math, right? We can kind of figure out what's going to happen if our firm, and I'm going to try to do a little bit of a text area. I'll see if I can type. I'm not so sure how that'll look on this. I'm using Screencast-O-Matic, experimenting a little bit, but we can just kind of do some math with this. If we know that this oligopoly is producing 2,000 gallons of olive oil and each one is $80, all we have to do is multiply 80 times 2,000. We get 160,000, so that's the total revenue. We also know that the total costs, okay, will be 40 is the cost for each unit times 2,000, okay? So if we take our total revenues minus our total costs, we should get 80,000. And 80,000 is actually for one giant oligopoly. Because we have two players and they're each distributing their profits evenly, we're going to find out that each oligopolist, right, the sopranos and the contraltos, should get the equivalent of $40,000. Okay, so let's see if I can note that. I'm trying to see where I can write that. Okay, let's see, text area right here, $40,000. Okay, I'm writing, but it's not typing. In any case, let's just do it this way, okay? It's going to be $40,000. 40K, okay, if we look at problem A, okay? For the next one, B, okay, this is pretty straightforward. We have a situation where there's going to be some cheating involved, right? These are two oligopolists who are deciding ahead of time they're going to price at 80 and they're each only going to produce 2,000 of the units. One of the families, the Sopranos, I believe, decide that they're going to produce an extra 500, okay? So this is basically kind of upping in order to get greater revenue, right? If they can sell some more, maybe they ultimately can increase their revenue. Well, what happens when they do that? In this case, we're actually going to be looking here because now the one family is producing an additional 500. Together, they're producing 2,500, and their price has decreased for both families that are selling, not only for the Sopranos, but also for the Contraltos. So in this case, we're going to be in a situation where both families are not going to be making the exact same amount of profit because one family, the Sopranos, is actually producing 1,500, and their revenue will be 1,500 times 70. The other family is producing 1,000 units times 70. Okay, so the total revenue is going to differ, and you can kind of do the math on that to kind of figure out the total revenue. For total cost, the total cost will be the 40, right? 40 is the marginal cost times the quantity of units. So for the one family, the Sopranos, it's 1,500 times 40. For the second family, it's 1,000 times 40 for a total cost of 40,000. Okay, so we should be able to figure out that one family is going to be making $45,000 profits, right? The family that cheated on the agreement, the Sopranos, will make $45,000 of profit, whereas the other family is just going to be making $30,000 worth of profit. So even though they're together combining and selling more, one family is benefiting while the other family is not. Of course, if we look at what happens next in Part C, we're going to see that the other family, the Contraltos, are going to increase the production another 500. Okay, so now they're going to be producing a combined of 3,000. In this case, each firm is producing 1,500 units. Okay, the price now is lowered to 60. Right, they have been in a position where they're increasing their units on the demand curve, so the price is lower in order to sell those increased units, and the price is lowering not only for the Sopranos, the firm that originally had cheated, it's going to now go down for the Sopranos and for the Contraltos. Okay, so in this case, each firm is producing 1,500 units at a price of 60. Okay, so that's their total revenue. I'm subtracting their total cost, which is going to be for each firm 60 times 40. Okay, and in this case, we should be able to do a total revenue minus total cost to figure out profit and see that for C, both firms are actually going to make 30,000 each. Okay, it's very, very possible that this could happen, right? It's there's a great deal of incentive to cheat. That's one of the reasons why oftentimes collusive agreements are not that stable. They may not be a Nash equilibria. There might be a great deal of opportunity to cheat. Okay, so for the first one, question A, they were each making 40,000. For the second question, the Sopranos had an advantage. They were making 45,000, whereas the Contraltos were stuck with 20,000. And the kind of response was for then both firms to experience cheating essentially on each other, and they were up to selling 3,000 units, but at a price only of $60. They would be experiencing a profit of 10,000 less than their original, right? So the bottom line is, and the kind of rule of thumb is that, collusive arrangements can be very useful when the agreement sticks, okay? If they didn't cheat on each other, they ultimately could be here at this $40,000 a pop. That might be pretty optimal for them. However, there is incentive to cheat. Cheating does not work well for either firm. I know this video could be much better in terms of the quality of me writing some of the details of this, but I hope that helped a little bit.